Welcome everybody, it's Mrs. Dunn, and what I want to do in this screencast is talk to you about Markov chains. So in this screencast, specifically what we're going to do is we're going to create a transition diagram, we're going to create a transition matrix called P, and we're going to apply powers of Markov chains to calculate the probability of an event. So let's get started. So let's look at this example. This is about student retention. Part-time students in a university MBA program are considered to be entry-level students until they complete 15 credits successfully. Then they are classified as advanced level students and can take more advanced courses and work on their thesis required for graduation. Past records indicate that at the end of each year, 10% of the entry-level students, E, drop out of the program, D, and 30% become advanced level students, A. Also, 10% of the advanced level students drop out of the program and 40% graduate, G, each year. Students that graduate or drop out never return to the program. Okay, just because I felt like I read that a little bit weird, just to be clear. An entry-level student is going to be designated as E. A dropout is going to be designated as D. Advanced level is A, and graduate is G. So what we're going to do is three things. First, we're going to draw a transition diagram for this information. Then we're going to draw a transition matrix. And then we're going to interpret this and find the probability that an entry-level student graduates within 4 years and drops out within 4 years. So to draw the transition diagram, we have to separate the information that's in here. We have to separate what we know about the entry level and what we know about advanced level. So for the entry level, we know 10% of the entry level drop out. We're also told in here that 30% of the entry level become advanced students. So 10% are dropping out, 30% are moving on. So who's left? Well, there's 60% left, and those students must remain entry level. Same thing is happening with the advanced level. We have 10% that drop out, 40% go on to graduate. So who's left? Well, half of the students, 50%, must remain at advanced level status. So what we want to do is we want to draw a transition diagram of this information. So here's what it looks like. E is entry level, D is dropout, A is advanced level, G is graduate. So look at this. I know it might look a little confusing with these lines coming out of here, but let's look at it one piece at a time. Let's look at E. What you want to notice are the arrows coming out of E. So notice the arrow on the end, it's coming out of E. All of the arrows coming out of this circle have to add up to 1. 0.6, 0.3, 0.1, add up to 1. We have to account for everything that happens with entry level. Same thing with the dropouts. Once you drop out, you stay a dropout. So those that drop out are staying and going back into being dropped out. And then we have the advanced level. From the advanced level, 10% are dropping out, 50% are staying advanced, 40% are graduating. And once you've graduated, you stay graduating. So that's what the transition diagram looks like. I think it's pretty easy once you get the concept. At first, when you look at it, it might be intimidating, but once you break it down, it should make sense. One more time, I want to show you. Look at the arrows coming out of A. Coming out of A. See, this 0.3 is going in, so we're not counting that one. Coming out of A have to add up to 1. 0.1 plus 0.4 plus 0.5 adds up to 1. Okay, the next step is to take this information and make our transition matrix. So remember those states: entry level, dropout, advanced level, graduate. Those are going to be the same when we label the columns and when we label the rows. Okay, sorry, rows and columns. So look at this information. What's happening? You're going to read this transition matrix coming in this way and going up. So from the entry level, going back back into entry level is 0.6. That's this number right here. Coming out of entry level, going into dropout is 0.1. Coming out of entry level, going into advanced, out of entry, into advanced, 0.3. And that means nobody that's in entry level graduates. Same thing for each one of these rows. Remember, right here, dropout into dropout is 1. We call that an absorbing state. Once you become a dropout, you stay a dropout. You're going to see that in the next couple sections. G is also absorbing because once you graduate from the program, you stay a graduate. Okay, let's go on and interpret this. So what's the probability that an entry-level student graduates within 4 years? To do that, we're going to find the fourth power of this matrix. If we raise P to the fourth power, that's going to show us what's happening in 4 years. So what we want to do is we want to enter that information into our calculator. So we're going to press second in matrix. And we're going to edit matrix A. I've already done this and I've already entered the information. If you want to pause the video right now and enter it yourself, feel free. But once you get all that information in there, you're going to quit. And then you're going to call up that matrix one more time. So second matrix, remember we put that in A, so we'll press A. And we're going to raise that using the caret button to the fourth power. The matrix does not show on the screen. If you toggle to the right, you'll see the whole thing. So we're going to go back and forth. I put this on this slide, and I just tried to center it and put it in the middle. But this is P to the fourth, which is showing us the probability of what is happening 4 years from now. So the way you're going to interpret this is, remember, we want to know what's the probability that an entry level graduates. So entry level graduates is this element in the matrix. And so from entry level to graduates, the probability of that happening in 4 years is 0.3612. Okay, so the next question was, what is the probability that an entry-level student drops out in 4 years? So why don't you try to see that? Look at the P to the fourth matrix and see which of those elements represents the probability of an entry-level dropping out. Did you think it was 0.3079? Entry level dropout 0.3079. I hope you did. Okay, that's all there is to it. Good luck.